Hi, I'm Don Cohen from Michigan Metrology. Michigan Metrology has been in business over 30 years now. I help people solve problems related to squeaks, leaks, friction, wear, appearance, adhesion, other things that relate to surface roughness. We use Bruker optical profilers to measure the 3D surface texture of all kinds of components. Typically, I measure anything from machine surfaces to very rough surfaces like a cast surface, and sometimes very smooth surfaces like you might find on an optical surface. A typical machine surface, like a ground surface, might have an average roughness of maybe 0.1, 0.2 micrometers. But when we talk about really polished surfaces, we can start approaching 0.1 microns to 0.01, which is, and even below 1 nanometer surfaces. So this machine has the capability to actually measure surfaces on the order of a nanometer or so. And it also has some more advanced features that are very recent, where we can now measure very smooth surfaces, but they don't have to be perfectly flat. Very early optical profilometers had a mode which is called phase shifting. And that phase shifting mode was limited to maybe measuring surfaces with 50 to 25 nanometer roughness. Later, we developed this technique called vertical scanning interferometry, which allowed us to measure rougher surfaces. The problem was always trying to combine those two, because sometimes you would have a surface that had some shape to it in which the vertical scanning could measure, but it couldn't measure the underlying smooth surface. Recently, Bruker came up with some really advanced technology which allows us to combine both of those techniques. The technique is called VXI, where all the various modes are under one umbrella. And I'm going to show you that technique here in a moment. This part we're measuring today is a very polished basic lens. When I'm in focus on the lens, we see this interference fringe pattern that's appearing. So at this point, I'm in focus on the lens, but over here in the field of view, I'm out of focus. As I move the microscope down, that fringe pattern moves down because it's basically moving down the side of the lens. I'm only in best focus in that little narrow area. So if we go and measure this with the, say, more standard vertical scanning mode of interferometry, the microscope's going to scan down vertically, and that fringe pattern will sweep across the surface. And as it sweeps across the surface, it's detecting best focus all the way along the line. But in the vertical scanning mode, we can only detect best focus to within a few nanometers, 6, 7 nanometers. We can see some underlying what we'll call long wavelength structures, but superimposed on them is all this fuzzy, what we'll say, noise-like structure, which is most likely not the surface texture. And if we only were measuring with VSI, we might be fooled thinking the surface looks this way. But we know from experience that this is just pushing the vertical scanning mode a little too hard. So if we really wanted to measure the pure surface finish of that, the best mode for that is the phase shifting mode. In the phase shifting mode, the fringes aren't going to scan from top to bottom. They're just basically going to shift, and we grab multiple images as it shifts to finally measure the height of the surface, but only over the region where there's fringes. So when I make this measurement, those fringes are only limited to a very narrow region. Over that region, I can do a great job of measuring the roughness. The roughness in that little narrow band is about 2 nanometers. What we've since developed at Bruker is this wonderful technique called VXI, which is now called USI for universal scanning. And what's done here is when it makes the measurement, it's going to scan the part just like for vertical scanning, but all along the way do phase shifting type calculations and able to put together both modes of measurement. You can see the difference. If we look at the VSI surface, we get what looks like that same surface, but it's got a lot of noise on it. If we look at the PSI surface, we can see the very fine texture, but we can't see the large field of view. Fortunately, the VXI surface is what allows us to see both the large field of view and the really smooth surface texture. This development has really led to a lot of capability I didn't have just a few years ago. Particularly not only in the optics world, I've done a lot of work lately measuring molded optics, where people are mass producing optical type surfaces used sort of like in the automotive industry. Also, we'll find this in the medical industry, a lot of precision polished surfaces, spinal implants, things of that nature. But now with this vertical scanning VXI mode, we're able to see a lot more of the surface and at the same time maintain the 3 angstrom height resolution. So this is just one of the many kinds of parts I measure. I've been involved in this technology for almost 40 years now. I work with Bruker Corporation as a value-added partner here in Detroit. Visit the website, mishmet.com. On there's a lot of resources. Also on that website is the ability to arrange meetings with myself. We can meet and discuss your applications. If you're in the Detroit area, feel free to set up a time to come by and visit, bring some parts. And again, just feel free to send a few samples in for no charge. I'll take a quick look and see what we can do.